And good morning, everybody. Here's an example of a optimization problem, and we're going to be looking to minimize the distance to a point on a curve. So here's the problem. It says find the point on the graph of f of x equals the square root of x that is closest to the point 3, 0. So let's go ahead and sketch a picture. So we have a square root function. And we have a point 4, 0. And they want us to minimize the distance from this point 4, 0 to the curve. So we're going to go straight up, or we're going to go to the left, to the right. So if we wanted to find the distance to the curve, x, y, they want us to minimize that point. So what we're going to need to do to find the minimum distance, we're going to need to come up with a function that represents this distance between these 2 points. One of the points is fixed, the 4, 0, but this point is going to keep changing until we find the point where we have a minimum distance. So we're going to need a distance formula. If you've forgotten your distance formula from geometry class, you can kind of recreate it pretty quickly. So if you think about finding a diagonal distance on a coordinate system, so if this was your distance, this would be at x sub 1, and this would be the other coordinate, y sub 1. This second point, we could call this x sub 2 and y sub 2. And basically the distance formula is just the Pythagorean theorem on the coordinate plane. So if we turn this into a right triangle, and we know that we have side A and side B, we know the Pythagorean theorem would say that a squared plus b squared must equal c squared. Or in this case, d squared, that's our hypotenuse, so the distance between those 2 points. And how would you find the value of a from here to here? It's just going to be the difference between x sub 2 and x sub 1. So it's going to be x sub 2 minus x sub 1 squared plus, and then the distance between here and here is y2 minus y1, so y2 minus y1 squared, and that's going to be that distance squared. And if you want to get d by itself, then you could just go ahead and square root both sides. So we can take the square root of the right side, take the square root of the left side, and that is going to be our distance formula. So it looks kind of long and complicated, but the way I remember it, the distance is equal to, it's going to be the square root of something. What is it the square root of? It's the square root of the sum of those squares that were on the legs of that right triangle. And how are you finding the legs? It was x2 minus x1 and y2 minus y1. And it doesn't really matter which one is the x's and which one's the y's, since you're going to square everything and just add them. So the order of the addition of these doesn't matter. And the order of the subtraction doesn't matter because you're going to square everything. So if you subtracted and ended up with a negative value, it's just going to be a positive value. So it's a pretty forgiving formula as far as where things can go. So that's going to be your distance formula. So now that we know the distance formula, it's going to be the square root of the sum of the squares of the legs on a right triangle. So we'll call it x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Remember, to find a min or a max, we're going to be looking for the first derivative of this distance formula. But we also want it just to be in terms of one variable. Right now it's in terms of variable x and variable y. So the trick to get it to just one variable, if we rewrite our ordered pair x comma y in terms of one variable x, x is going to be the first variable, but what was the definition of y? So y was said to be just the square root of x. So this is in function notation. This is the same thing as saying y is equal to the square root of x. So instead of putting y into the ordered pair, we could say this is always just going to be the square root of whatever x is. And then we can put this into the distance formula. So distance equals, it will be the square root. And we want to subtract our x's, so we could go x minus 4. So we want to subtract our x values, so this one and this one. So it's going to work out to be x minus 4 all squared plus the difference in the y squared. So that's going to be square root of x minus 0. So we're going to get square root of x minus 0 squared. And before we take the derivative, we want to simplify this. So let's say distance is equal to square root. We can square out the x minus 4. So x minus 4 squared should be x minus 4 times x minus 4. Multiply that all together, that should get you x squared. Minus 4x and minus 4x is minus 8x plus 16. So this will work out to be x squared minus 8x plus 16. And the next one, we have the square root of x minus 0 squared. So square root of x minus 0 is just the square root of x. Square that and you just have x, so it's going to be a plus x. And then simplify your radicand, what's inside here. So x squared minus 7x plus 16. And now we have a nice clean function that represents the distance by knowing just what the x value is. And we know mins and maxes occur where the first derivative is 0 or undefined. So the next job is to go find the first derivative. So let's take this and go find the first derivative. So here's our function d, finding the distance, and we need a d prime. Let's go ahead and rewrite this using exponents. So it's going to be x squared minus 7x plus 16 to the 1/2 power. And we're going to find d prime, so we'll call it d prime of x is equal to, we're going to have to use the chain rule, so 1/2 x squared minus 7x plus 16, drop it down a power, so negative 1/2, and multiply it by the derivative of the inside function because of the chain rule, so that's going to get us a 2x minus 7. And that's going to be our first derivative, and then we can rearrange this. So put things in the right place. So let's see, the 2 is down bottom, the x squared minus 7x plus 16. If we bring that down bottom, that's going to be a positive 1/2 power. And then the 2x minus 7 is up top. And we're looking for critical numbers. That's going to be where d prime is 0 or undefined. So where could this function be 0? It's going to be 0 if the numerator is 0, so we can set this equal to 0. So where is 2x minus 7 equal to 0? Solve that, add 7 divided by 2, that's going to be where x is 7/2. And where can it be undefined? It can be undefined if the denominator is 0. So what's going to make this denominator 0? Essentially, if this right here is 0, because you would have the square root of 0, which is 0 times the 2 is 0. So we're looking to see where this quadratic, the x squared minus 7x plus 16 could be 0. And you can either solve this by trying to factor it, quadratic formula. You could make a graph of it. If you have access to a graphing calculator, I would just graph it first and see if there even are any zeros for this function. So if you were to make a graph of it, you would find that it's actually above the x-axis. Maybe something like this. So there is no place where it's going to cross the x-axis. So it's never going to be 0. It has no zeros. So we're going to say no solution on this one. So the only critical values you have are this one right here, where x is equal to 7/2. So this is going to be your critical number. So that's where you're going to get a min or a max on the other function. So if we go ahead and go back and look at the original function for the distance. So this was our distance formula. We were trying to minimize it. We know the minimum is going to happen at where x is 7/2. So we know the x value now is 7/2. So what would the y value be if we put that back into the equation? So the original function here. So we know y is equal to the square root of x, and we know our x is just 7/2. So the y coordinate is going to be square root of 7/2. And then go back and make sure we answer the question. It says find the point on the graph of that function that is closest to the point 4, 0. So they wanted the point, and there is our point. There is our ordered pair, where we would minimize that distance from 4, 0 out to the curve.